Hello students, welcome back. We just talked about an alternative problem, similar problem with different data set, and we talked about how to produce histogram when a class interval is given. What do we do? And well, here's a data set, original data set, or if the original data set is not given, if you have some 7-leaf display like this and you have to figure it out on your own, you can do that. I'm not going to give you super many, maybe about 20 or so maximum. So you can write all those down from smallest to the largest and then count accordingly to produce frequency table. Once you have the frequency table, you can produce histogram like this. And each class interval goes to the horizontal and frequency goes to vertical. Those are two key characteristics of histogram. The others, like rectangles touching each other, those are not that important. Real key is, number one, class interval horizontally. Number two, frequency or relative frequency vertically. Now let's talk about ogives. Okay, ogives are relatively less important, but okay, here we go anyway. We have frequencies and we count cumulative frequencies. Well, we already counted frequencies, so let's just copy and paste those. Okay, and cumulative frequencies, and this is for 200 to 220, so there's one. And this one, cumulative. So not starting from 220, but 200 to 240. So what are those? 1 plus 2, that's 3. And this one is cumulative again. Small as 200 all the way to 260. So you have to add these up. Making sense? It's cumulative. And then next, 7 plus 7, so 14. And then final cumulative, you have to add them all up. That should be the total. Making sense? And using these two, frequency table and also cumulative frequency table, you can produce two graphs at the same time. One is histogram down here, okay, and the other is the line graph, starting from this cumulative, the smallest one, yeah, here, and then cumulative, so add them up. Cumulative, so adding them up. This line graph must steadily going up because it's cumulative. It can never come down, you see. If you add negative number, of course, you'll have decrease. But if you count, you're not going to get negative number of people or anything like that. So this line graph is always going up. Putting these two together is called ogive. Now, as for homework problems, there are plenty of ogive problems because you have indefinite amount of time, and it's an interesting concept anyway. But for exam preparation, I thought this was excessively time-consuming. And then because of the scaling, the histogram part, the real important part is a bit too squished and it's a little bit hard to see unless you use two different scaling, which is opening up another door, more complication. So as for exam preparation, I'd like to place some less amount of attention to this one. Histogram is extremely important. As I said in the previous video, I never miss it. But ogive, not that important, even though it's an interesting concept. Now let's go over to problem 2. And problem 2 is basically a repetition of similar things, except that you're asked to figure out your own class interval. And what do you mean by your own class interval? Well, if this had been, let's see, great distribution of a certain class, for example, well, maybe that was for the previous class because, previous example, excuse me, the original example here, because that one was going from 0 to 100, or nobody scores something close to 0, from 57 to close to 100. It looks like really a score distribution. So consider yourself as a professor and giving letter grade, but this was a little bit different. Going from 200 to 300, what kind of data? I don't know. I just made those up as a matter of fact. And maybe you're going to need a little bit different class distinction. And in this particular case, I have 1, 2, 3, 4 bunches clearly separated out. So in this particular case, I want to be a little bit more clever about, getting those distinctions, so that if I just use, let's see, cutting from 280, then 280 to 300, all these 4 data are considered as the same category. But if you look at this dot plot, they clearly look different. We may be looking at completely different characteristics. So I'd like to have a separation between those two, and around here. And this one is likely an outlier if this is some kind of measurement. And it is quite possible some experiment mistake or some recording mistake. Typically, this kind of thing should be casted out. But that's for a real-life example. This is math class, so we'll include this one as well. Anyway, you need to be a little bit clever about setting appropriate class interval. And there are several ideas. One is, let's see, instead of going over to 20, let's go to about 15. 300, 285 around here. Next 15 is 270. 270 to 255. And then 240 like that. And that's where I'm a little bit uncomfortable. If I cut at 240, then this bunch is being separated out. So that may not be a very good class interval. But still, if you decide like that and then count frequency and then relative frequency if necessary and produce a histogram based upon this, that's going to be worth full credit. Another suggestion, how about the second one down here? And let's minimize this one. And instead of starting from 300, I started from 310, went a little bit further, and then go to 20. So let's cut it at 290 right here. And the next one cutting at 270 around here. And the next one cutting at 250 around here. And the next one cutting at 230 around here like that. So these 4 bunches are clearly separated out if you use this scheme. And still you have same size of class intervals. So that's okay too. You can do various things. This problem gave you freedom. So you do whatever that you think is appropriate. Just remember one thing. In 1000 level, we are dealing with only the class intervals of same width. If you have variable width, then things are quite a bit different. And in 3000 level course, Math 3680, that's where we cover it. In 1000 level, we don't consider that. And in case there is a student who is curious, let me spend just a couple of minutes on it. Normal students probably wouldn't care. So you can just stop this and then just move on. So in this data set, here's a standard histogram with interval length as 10, so 90 to 100, 80 to 90, 70 to 80, and so on. And class intervals are here, 0 from 40 to 50. So we have rectangle, but height is 0. And each rectangle represents, the height of each rectangle represents a frequency. And if you have some different class intervals, you get a little bit different histograms. These are standard histograms, if even width. For uneven width, this is a wrong histogram and that's correct histogram. If you just use frequency, you get wrong histogram. It looks like, let's see, from 30 to 50, there was 1. From 50 to 60, there was 1 as well. 60 to 65, there was 1 as well. But are they equally as important? No, not really. 1 from this 20 range and one from this 10 range and one from this 5 range have different probabilities there. They should have different heights. And this is advanced histogram, and their frequencies or relative frequencies proportional to areas of these rectangles. Area. And how is area related to other part of mathematics? It is related to antiderivatives and integrals. Okay, I just opened up the can of worms. And that's why it is going over the 3000 level math course. It is related to calculus. As for 1000 level, please stick to interval widths of same size. 30 to 40, 10, 40 to 50, 10, 50 to 60, 10. You get the picture, right? Same width. That's what we're going to do for 1000 level math course. So if you meet some, if your major course or whatever, in some other course, if you encounter a histogram with uneven width, it's an alert. It's not 1000 level math course. We are doing something different. Now, if you're creating your own data set and some statistical analysis for your own project, make sure you do something easy. That is, get interval size of same width so that you can actually do something about it. If you create something so that you have uneven interval width, and now you can't do it on your own, you're going to need help, then the project will become much harder for you. Don't do it. My emphasis, in 1000 level at least, interval width, the class interval width must be the same all the time.